Hi, hello everyone. In this last video regarding chapter 10, we will discuss about rate of change, that is by using chain rule. Right, in the question 8, we skip question A because the example is not using chain rule. So we straight go to question B. So a ladder 5 meter long is leaning against a vertical wall and is sliding down the wall. When the foot of the ladder 3 meters away from the wall, the top of the ladder slides down at the rate 0.5 meter per second. At what rate is the foot of the ladder moving away from the wall at this instant? So below that is a diagram of the ladder that is leaning against the wall. Right, so this is the wall, this is the floor. So we can define x here and y at the wall. Okay, so the equation using Pythagoras theorem is x squared plus y squared equals to 25. That is 5 meters, 5 squared is 25. So this is the equation that we get. And then from the equation also, at the situation when x equals to 3, so we write down at x equals to 3, the rate would be 0.5. So the sign negative here because it is slides down. So when slides down, it will be negative because the length of the wall will be decreased. Okay. So this is the equation as I mentioned before. So from the equation, we can straight away differentiate implicitly. So x squared will become 2x and y squared will become 2y. And then don't forget, because it is in terms of x, so we have to put dy dx after y. And then differentiate constant is 0. So the differentiate 2x plus 2y dy dx equals to 0. Then we can rearrange to make dy dx a subject. So after we simplify, right? So we'll get negative x over y. Right. This is what I said before. Because it is slide down, the rate is negative. And then here we will apply the chain rule. So basically the chain rule dy dx, as we know from the previous chapter, it is equals to dy dt times dt dx, right? So dy dx we already obtained above. Dy dt slides down. So slides down dy dt negative 0.5. So this is 0.5. So you want to find out dx dt. So we made dx dt as a subject. So with that, we need to reverse from dy dx. Now it will become dx dy. And then dy dt remains same. Okay. So with that, from dy dx equals to negative x over y. So now if we want to make dx dy, it will be negative y over x. Okay. So with that, we can substitute into our chain rule. So dx dt equals to negative y over x, that is dx dy. And then dy dt already given in the question, that is 0.5. And also, you have to substitute the value of x and y. So the value of x given when x equals to 3. So when x equals to 3, you have to find out the value of y. So remember, this is the original question. X squared plus y squared equals to 25. So we rearrange. So y would be 25 minus x squared and then square root. Okay. So that's why it will become like this. Square root 25 minus x squared. So x is 3. So x squared is 9. So we know 16 is equals to 4. So y equals to 4 when x equals to 3. So with that, we can calculate the value of dx dt. So substitute y4, x3, and then negative 0.5 already there. So negative, so final answer dx dt should be positive. Okay, so positive 2/3 meter per second. Just to take note over here. So the unit is not compulsory. Okay, you can write down the unit or not. There will be no deduct in marks, okay, unlike the other subject. So for maths, we concentrating on the working step. So final answer, if you don't put a unit meter per second, only 2/3. So it's okay if you don't put the unit, we can still accept the answer, no problem. Right, so next for question C, an oil tank is in the shape of an inverted. So inverted means reverse. So this is the normal cone. So that one, it will be inverted cone. Radius 20 and height 8 meter. So as you can see, if when we put 20 and 8 and we construct a triangle, so somehow when R, the radius is R and the height is H, the angle is remain same, that is theta. So with that, we can relate tangent theta, that is R/H, equals to 20/8. So this ratio will remain. So with that, using the relation of tangent theta here, we can relate R with H. Okay. And also, as you can see, as I highlighted above there, the dV/dt is 45 meter cubic per minute. And also given when H equals to 3, we want to find out dH/dt. Okay, so this is the information given from the question. Right. So now from the relation R/H here, so we can rewrite. So R equals to 5/2H. Okay. And then since we given the dV/dt, so of course you are dealing with volume. So the volume of the core, remember, is 1/3 pi r squared H. And since we want all in terms of H, so we want to substitute this R. So we substitute with 5/2H. So now it will become like this. And then we expand, simplify. So at the end, we will get 25/12 pi H cube. Okay, so that's the equation of volume. So after we obtain the equation of volume, don't forget we have to differentiate in order to get dV/dH. So differentiate, we get dV/dH 25/4 pi H squared. And then remember, later we have to use a chain rule. And then remember from the previous example, we have to inverse, right? So in this example, since later we know we have to reverse from dV/dH to be dH/dV, so we straight away write down here. So dH/dV, so you notice only 4 below. So when we reverse upside down, so 4 will become upside. So downside 25 pi H squared. Okay. Right. And then we can proceed with the chain rule. So chain rule from dV/dt. So now we put dH/dt as a subject, since the question asks about dH/dt. And then as I mentioned before, we have to use dH/dV. Okay, so we already reverse dV/dH to get the dH/dV. So after that, no problem, you just substitute over here. And then dVdt already given 45. And then don't forget our situation here at h equals to 3. So substitute h equals to 3. So our dH dt, so you just plug in all this in the calculator, into the calculator. Then we get the answer is 0.255 meter per second. I just like to remind all of you, the final answer should usually in 3 significant figures. So it should be 0.255. If you just put 0.25, that won't consider as a final answer, because final answer must be at least 3 significant figures. Okay. Right. So now look at question D. The shape almost same, right? There is an inverted cone. But in this situation, instead of we pour in water, so in this case, the water is leaking down from the bottom. Okay. So the water is leaking down. So originally the size of the tank is radius 1.5, height is 2 meter, and then the rate of leaking out water is 0.25. So the situation when h equals to 1, find the rate of change. So the rate of change water level here actually refers to dH dt. And then below here, the rate of change or radius of water surface here actually represent dr dt. Okay, so this is what the question asks. Okay, and also look at the diagram over here. Right, so like the previous example, we can relate r with h using the tangent, right? So tangent r over h 1.5 over 2, so we can simplify, so it will be 3 over 4 lah. Okay, and then the rate is given 0.25, and then notice here, okay, the sign is negative because it is leaking. Okay, so since it's leaking, you have to put negative sign. And then, right, as I mentioned, the first one, the question asks about dH dt, and the second question is asked about dr dt. So first we are dealing with dH dt first. So since you already know relation between r and h, so r equals to 3 over 4 h. And then remember, from this relation, we will substitute into our equation of volume. Okay, remember, so the equation of volume is 1 over 3 pi r square h. Okay, same as the previous example because the shape is same. There is cone. And then remember also we have to substitute r with 3 over 4 h here. So it will become like this. And then we simplify. Then it will become 3 over 16 pi h cube. Okay. Right. So remember, after we obtain the equation of the volume, next we have to differentiate. So differentiate will get dV dH. So differentiate, remember, apply the concept of differentiation, power rule. Then at the end we got 9 over 16 pi h squared. So that's dV dH. And then remember, from previous example, usually we have to reverse, right? So from dV dH we reverse to get dH dV, that is 16 over 9 pi h squared, right? Okay, next we want to find dH dt, right? So using chain rule, dH dV, okay, so this is dH dV, we already upside down from dV dH. And then times dV dt already given negative 0.25. So we just substitute these two, dH dV and also negative 0.25, that is dV dt. And then don't forget also at h equals to 1. So substitute h with 1. So calculate using your calculator. So at the end, our DHDT is negative 0.141 meter per minute. Remember, as I mentioned in the previous example, the unit is not compulsory. If you don't write down the unit, the answer is still correct. Okay, but remember, since DVDT we have negative over here, so our final answer also have negative. Okay, because since it is leaking, the level of water would be decreased. Okay, so since the level of water will be decreased, of course DHDT must have negative sign. Okay, remember that. Okay, next we want to find the second question, that is DRDT. So how we find out DRDT? Very simple actually for this one. Actually, we will use the relation from tangent theta, that is R over H 3 over 4 will be R equals to 3 over 4H. And then what we will do here actually very simple, that is we will differentiate with respect to T. So dr will become drdt, H also will become dHdt. That is like this one. Okay, very simple. And then from previous question, actually we already find the dHdt, right? That is negative 0.141. So we just substitute that dHdt, then we can straight away find out our drdt. Okay, see, very simple. So we got drdt negative 0.106 meter per minute. Again, as I said before, the unit is not compulsory. You can choose not to write down the unit and you can still get the full marks. No problem. As long you don't miss out the negative. So remember, we still have negative. Okay. So that's for this example. Example D, I think. Right. So now we move to the last example in our video here. That is, milk is being poured into the hemispherical bowl of radius 4 cm at the rate of 3 centimeter cubic per second. Right, so the equation of volume in this case, since it is not a simple cone, so the equation already given, equation of hemisphere. So we just straight away use this equation volume, right? Right. So at instant of 1 cm deep, right? So take note, the statement deep here actually represent h, height. That is when h equals to 1.5. So find the rate of change of h, that is dHdt. So the question here actually asks for dHdt. And then the rate of change of the radius, so this one is drdt. I think quite similar to previous example, right? First, they ask about dHdt, and second, they ask about drdt. Okay. So let's see the solution. So the solution, I think, on the next slide. So let's see on the next slide. Okay, correct. The first question asks about dHdt. The second question, drdt. Okay, next. So the first question about dHdt. Right, first from the equation volume given, we will differentiate. Okay, differentiate to get dVdH. So after we simplify 3 over 3 there, then we get pi times 8h minus h squared. Okay, so that's dVdH. And then next, remember, usually we have to reverse, right? So we straight away find dHdV. So it will be 1 over lah, because we don't have any fraction over there. So all of this term will be at the denominator. Okay, so 1 over pi times 8h minus h squared. Right, next we apply the chain rule. So dash dt, dash dv, so dash dt is already here. Okay. And then dv dt already given, I think 3, yeah. So we just substitute all this value, and then okay, straight away we substitute h. We don't to substitute 2 times, substitute formula and then substitute h. We just straight away substitute dash dv and also h with 1.5. So it will be like this. So substitute dash dv together with h at the same time. So we can straight away find the value of dash dt. Okay, take note of this answer here. If you press your calculator will give a 0.0979 something, which will, if we round up, it will be 0.098. However, this is only two significant figures. Since our final answer need in 3 significant figures, so you have to put 0 at the back, so that the final answer would be in 3 significant figures. Okay, so take note about that for dash dt. Right, so next, to solve question, the second part of the question, the SDR dt, first you have to check out the relation between R and H. Remember, this time it is not a cone and it's not simple as the cone. So from the previous diagram, I just crop down the most important one here, that is the above triangle here. So from the above triangle here, so the length of this side is 4 minus h, the length of this side is actually r, and then the hypotenuse is 4. Okay, so we can write down that to get r, that is r squared, it is 4 squared minus 4 minus h squared. Okay, so this is actually from Pythagoras, Pythagoras theorem. And then before we find the value, we know that we have to differentiate, right? Remember the previous example regarding cone, r in terms of h, so we differentiate, right, to get the r dt and dash dt, right? So same also here, but now since it is r squared, so we differentiate, we get 2r, and then we put the r dt at the back here. And also this one is constant, so differentiate, we got 0. And this one is a power rule actually, so differentiate 2, so you have to put 2 at the front, so the power of 1, and then you also have to differentiate inside h here, so we got negative 1 over here, then we put dash dt at the back. Okay, so if after we simplify, we will get this one lah, eliminate 0, and then simplify the negative. And notice that we have 2 on the both side, so we can cancel out 2. Then we got the dt equals to 4 minus h over r times the h dt. Okay, right, so since we already obtained the dt and also in relation with the dash dt, now we want to find out the value of r when h equals to 1.5. So use the same equation that is from the Pythagoras theorem. So when h equals to 1.5, so we just substitute. So we bring square to become square root on the right hand side. So square root 16 minus 4 minus h. So substitute h with 1.5. Okay, so straight away press your calculator and we get 39 over 2. That is the value of r. Okay, next, remember from the previous question, that is part 1, we got 0.0980, right? And also we already calculate the value of r and also h already given. Then we plug in all this value into the equation of dr dt and dash dt. Okay, And then straight away we can find out the value of the RDT. That is 0.0785. Right. So this time for this example, I don't put the unit. As I said before, the unit is not compulsory. You can still get the final answer full marks without putting the unit. Okay, no problem. So that's for this example. Right. So I hope you understand what we already discussed about rate of change. And then don't forget to answer the question in the tutorial. And also, if you notice that this is the last video regarding chapter 10. And also, chapter 10 is the last chapter in our syllabus. That means that it also the end of the syllabus SM015. Okay. So, what we do after this? So, after this, we will do revision, okay, before final exam. So make sure you do your best and prepare very well before your final exam. Okay, I wish best of luck for all of you. So with that, thank you very much.